Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll solve a problem on flow through branched pipes. In our previous lecture, already have discussed the theory part regarding the flow through branched pipes. So based on the theory, let's solve a problem on that particular topic, flow through branched pipes. So for that, we have taken a question of three reservoirs A, B, C are connected by a pipe system, which is shown in the figure here, and find the discharge into or from reservoir B and C if the rate of flow from the reservoir A is 60 liter per second. Find the height of water level in the reservoir C. Consider the F equal to 0.006 for all pipes. So here we can see the diagram, like this is one reservoir and this is another reservoir. So three reservoirs are there, A, B, C, three reservoirs are there. All are situated with different heights. Okay, that height also given, that is Z1, ZA and ZB, and this is ZC. So ZA is already given. This is the height of the reservoir 1 or reservoir A, we can say. This is the height of reservoir B. So this is ZB. This two height is given, and we need to calculate the height of this ZC. Along with that, also we need to find the discharge. The discharge from into or from reservoir B and C. What is the discharge from here and what is the discharge towards this. So we need to calculate. That means the water is flowing through a reservoir A and it is moving like towards this one. And also you can see there is a movement of this direction also, or you can take in this direction movement is there B to D point, B from B to D. Again, this is the junction point. This is actually junction point, you can say. This is ZD. Okay. So anyway, for all these reservoirs, all these three reservoirs are connected through different pipes are there and different lengths of pipes. So here we can write the data, what are the data are given here. Let's solve this. So the data are given here. Let me write here. This is length of first one, A to D. The length is L1 equal to, this is 1200 meter, and the same thing, discharge diameter of the pipe is D1 equal to, this is 30 centimeter. So this 30 centimeter also you can write in terms of meter also you can write it. So this is 0.3 meter. And next is, so here is the discharge also given. What is the discharge from this A to D point? So the discharge from A to D point is nothing but Q1, and this one we can write in term like already given in the question, that is 0.06 meter cube per second. Similarly, A to D completed. Now, what is the reference point is there? ZA. So ZA is the height. ZA is the height of this reservoir A from the datum line. So that is, we can write 40 meter, already given. Now similarly, the pipe length to second pipe is there, that length is L2. So this is L2 is connected from D to B point. So that is given 600 meter. 600 meter. What is the diameter of that particular pipe? So diameter, let's consider D2 is already given actually. So simple, we can just copy paste that one, what the value is given from there, and let's write this value 0.2 meter. And here also for this particular things, the Z, the distance from the datum line to the reservoir surface level, this one up to the here. So that is ZB. This is 38 meter. This is 38 meter. And coming to the length, third pipe, length 3, L3 equal to 800 meter. And diameter D3, you can write this is 30 centimeter. And similarly, yeah, ZC is not given, we need to calculate ZC actually. So ZC need to be calculated. So first what we will do, we will solve one by one actually. So let first apply the Bernoulli's equation. Apply the Bernoulli's equation from this is the surface point actually. So Bernoulli's equation need to be applied at a particular two sections or any two places, like starting of that fluid flow and ending of the fluid flow. So here what we will do, let apply the Bernoulli's equation by considering this is the height of this starting, and this is the next height of this. So we can write what? Apply Bernoulli's equation from, or you can say between E and D. Apply the Bernoulli's equation between the, because the E surface is here and D is here. So what we can write? We can write ZA. This is the formula, ZA, because ZA is the height, total height of this, equal to ZD plus PD by rho G plus what is the head loss. What is the head loss identified between A to D flow. So this is the formula for this. So this formula already we have discussed in the previous video lecture. Simple. At this section we can apply Bernoulli's equation, that is P by rho G plus V square by 2G plus Z1, and equal to P2 by here. This is PD by rho G plus Vd square by 2G plus Zd and plus HF1. So their pressure value and kinetic energy value will be neglected. That head will be neglected, and remaining things are here as usual. So here one more thing, HF1. So HF1 actually we know that this is the loss. So this is actually major loss. So for this also one formula is there, 4FL V square by 2DG. Though it is applicable for the first pipes, so we can write 4F1 L1 V1 square 2D1. So this is the value of this. Now here if you see F value is given, I hope, yeah, this is F value for all this F1, F2, F3. We can write all are same. Here F1, F2, F3 equal to F we can write, and that is equal to 0.006. So F value given, L value also given, V value not given in this, and D1 given, G given. So we know that discharge given Q, so Q by A, or you can write Q1 by A1 equal to, this is V1. So we can calculate this one value. What is the Q1 value? Let write this 0.06 divided by pi by 4 D square. This is pi by 4, D square is 0.3 square diameter, this one. Okay, now so let's take the help of this calculator. So 0.06 into 4 divided by pi equal to this much, again divided by 0.3 equal to 0.3, 139. 139. Okay, let's see one more time, because this much won't come here actually. Let's write one by one. This is V1 equal to, let's write how much will come. I'll do one by one thing. 4 into 0.06, 0.24. Okay, this is 0.24, and divided by, this is 0.3 square into pi, 0.282, 0.282. So let's see, 0.24 divided by 0.282, 0.8851. This is correct. 0.851 meter per second. So this is the velocity at this point. Now we just need to put this value on this HF1 so that we can calculate the head loss. So HF1 equal to F into 0.006 into L1. L1 is given here 1200 into V1. V1 square, this is 0.851 square divided by 2 into D1. D1 value 0.3 and into 9.81. So let's solve this. This much square. Square of this is this one, into multiply 1200 into 0.006 into 4, 20.86. Okay, divided by bracket start 2 into 0.3 into 9.81 bracket close 3.54. So this is the head loss, that is this is equal to 3.54 meter. Now put this value in this equation. So finally what I can write here, what is the value of ZA? ZA is here 40, so let's write 40 here, equal to ZD how much? So ZD value not given, so let's write ZD plus PD. This is PD actually, pressure at this D point, or pressure head we can say. This is total PD by rho g equal to pressure head. So this one also not given, just to write, we'll keep this value as usual, by rho g plus what is the value of HF? This is 3.54 meter. Now we just we can say solve this one. ZD by PD by rho g, ZD plus pressure at D point by rho g equal to, we'll take this value to this side, 40 minus 3.54, we'll get 36 point something will get, 36 point, and this is 46 something will get this much meter. Now here we can get it the value of, this is the piezometric height, this is the piezometric height of this, because see this total is nothing but piezometric height of this value. So that is at D point, D point, this is the value piezometric height. Now we know that here we can get the value of ZB. ZB is 38 meter. So the water should flow, you can see this is the, how much value is the 36, but here if you see the value 38, that means which is more than this value. So 38 means this is the height is more, so the water supposed to flow from B to D point. Okay, the water should supposed to flow from this B reservoir to D point. Okay, now what we'll do, we'll apply the Bernoulli's equation. Now we can write, apply Bernoulli's equation from, or from in the point between B and D. So again for this also we need to write equation. What the, for this particular B to D point, we can write this equation, that is nothing but ZB equal to ZD plus, again same equation we can write like PD by rho g plus HF2. Okay, so similarly what I can write here, HF2, let me keep HF2 here, remaining all the values I know actually. ZB equal to 38, and this is, if I will calculate this value, then this, all this term I will take it to the left hand side. Let me give this equation. Yeah, now it is very simple, we can easily find out the head loss between this point, that is 38 minus what is already there, 36.46, 36.46. So we'll get 1 point something, will get it 1.5, 1.54 meter. So this is the head loss in this pipe. Okay, now here velocity 2 we have not calculated actually in this point. So directly without calculating the velocity 2, we have identified the HF2 by using this formula. Okay, so now again we will just, what we'll do, we'll just calculate, because discharge need to be calculated. Here discharge is not given, you can see the discharge is not given, here discharge given, but the second pipe the discharge was not given. So what I'll do here is, again we can write the formula is HF2 equal to, we can write 4F2 L2, and this is V2 square by 2 D2G. So simple, I can write 1.54 something is there HF value, and here I can write 4 into 0.006 into the length we need to check it, 600, length is 600 into V2 square, value not given, and this is 2 into diameter 2, 20 centimeter, So this is 0.2 into 9.81. So we need to calculate the value of velocity. So I'll keep this velocity value here, and remaining value I'll take it to the other side. 1.54 into 2 into 0.2 into 9.81 divided by 4 into 0.006 f value. Length is 600. That's it. So this one I can solve it. Let's do this. 1.54 multiply 2 into 0.2 into 9.81. Okay, divided by bracket start 4 into 0.006 into, this is how much, 600 length, yeah, into 600 bracket close, 0.147 0.147. Okay, so now we'll just find out root over of this. Root over of this is nothing but 0.383. Let's calculate again. V2 square equal to 1.54, yeah, 0.2 into 2 into 9.81 divided by 4 into 0.006 into 600, correct only. 1.54 into 2 into 0.2 into 9.81. This is 6.04. Let me write one. 6.04 divided by 4 into 0.006 into 600. 14.4. 14.4. Now 6.04 divided by 14.4. Now root over of this, yeah. So this one directly I can write here, V2 equal to something 0.647 meter per second. Now this is the velocity 2. So once I got this one, immediately I can calculate the value of Q2. So Q2 equal to, I can write A2 V2. So here A2 V2 I can write pi by 4. This is 0.2 square into, this is velocity 0.647. So just to calculate this value, this one multiply pi into 0.2 into 0.2 divided by 4, 0.0203. 0.0203. So let me write 0.0203. This much discharge meter cube per second. So these things again we can write in terms of liter per second. So we can write this is 20.3 liter per second. This is the discharge from this. Okay, previously also we have calculated the discharge value. This is the Q velocity, and okay, previously already discharge given, we calculated the velocity. Now discharge we have calculated. Okay, now this is the second one. Third one, again if you need to go for the, because we need to calculate the discharge as well as we need to calculate the ZC value, this one ZC height. So again what we'll do, we'll apply the Bernoulli's equation, from in between D and C. So again the formula we can write here, ZD plus PD by rho G plus, or you can take what we'll do, ZC we can take it to this side, or in the right hand side also we can keep it, that we can write here ZC plus HF3. So here this value already we have seen there previously, ZD plus PD by rho G. This value already you can see here. This is the value 36.46 meter. So the same thing we can write 36.46 equal to ZC value not given, and we need to find out the HF3. HF3 value is we can write this is 4F L3 V3 square by 2D3G, and here what are the unknowns are there? V3 we can calculate here. So V3 equal to, again I can write Q3 by area, so pi by 4 d square. So Q3 actually, if you see there, like previously if you see here, Q3 equal to what? Now Q1 plus Q2 equal to Q3. Okay, so that one we can write there. So Q1 plus Q2. So Q1 how much given? 0.06. So what I'll write here, this is 0.06 plus, and this one what I can write, 0.02 we can write 0.0203 divided by area, pi by 4 d square, pi into d square. D how much is there? 30 centimeter. So 0.3 square into 4 I have taken to up. This is the velocity. So if it is there, we can write, let's solve this one again. So 0.06 plus 0.0203, how much is there? Okay, multiply 4 and divided by 2 into 0.3 into 0.3 bracket close, 1.784. So this is the velocity, 1.784 meter per second. Okay, I hope it is correct. So let's write down, this is the value, and put it in this equation. Let me check it one more time, because sometimes we used to get some different value. This will be 0.06, so you can get it here, 0.0803. This is this one, and pi by 4 d square, multiply of 4, and this is pi into 0.3 square, correct only. Okay, one more time list, 0.0803, correct, multiply 4, how much, and divided by bracket start pi into 0.3 into 0.3 bracket close, 1.136. okay, 1.136, this much meter per second, velocity 3. Now we'll just put this value in this equation, and we can write ZC equal to 36.46 minus all this value, let's put it here, 4 into 0.006 into L3 how much? 800. L3 is 800 into V3 square, so 1.136 square, and divided by 2 into 0.3 into 9.81. just to calculate this value and just minus from this one, so we'll get finally ZC. Anyway, just to calculate this, how much we'll get here, 4 into 0.006 into 800 into 1.136, again 1.136, 24.77, divided by bracket start 2 into 0.3 into 9.81 bracket close, 5.886, multiply and divided with 4.20. So 4.20, yeah, minus will do one thing, minus 36.46, minus 32.25, that is 32.25 only. This is 32.25 meter. So this much head of the sea. The reservoir sea is there. What is the height of the reservoir? That was asked in the question. So this is the answer for this. Now see, once you check it whether all these things are calculated or not, we need to find out the discharge into or from the reservoir B and C. What the discharge is there. So discharge Q2, Q3 need to be calculated. So Q3 we have identified because we know that. Again, we can write one more thing. Q3 equal to Q1 plus Q2, that we have implemented in this equation. And this is the ZC. Let's see. Find the discharge into and or from the reservoir B and C. We calculated. If the rate of flow from the reservoir is A is 60 liter per second, find the height of water level in the reservoir C. In this water level height, ZC, that need to be calculated. So finally we got this one, ZC equal to this, and remaining discharge also we have calculated. So I hope you understand this problem, how to solve it. Though little bit critical is there, that means number of things need to be solved. And these questions also will be asked, like a long question in the exam, like 10 marks questions will be there. If you're having any kind of query and doubt regarding this, you can give a comment on the comment box. Thank you.